Welcome back to The Explainer. Today, we're looking at a massive, often invisible challenge in software development, managing enterprise design documentation. I mean, if you've ever worked on a digital product, you know that keeping documentation aligned can be an absolute nightmare, right? Think about the sheer scale of an app like Uber. How do they keep everything perfectly aligned between what the designers dream up and what the engineers actually build? Well, today, we're unpacking exactly how Uber solved this massive documentation headache using AI. Okay, let's dive into this. 7. Uber doesn't just build one simple app. No, they maintain a massive design system across 7 entirely different implementation stacks. We're talking UKit, SwiftUI, Android XML, Android Compose, Web React, Go, and SDUI. Now, just imagine you design a new feature. You need documentation that acts as the single source of truth for all 7 of those platforms. When those specs fall behind or, get updated on one stack but not another, engineers have to start making assumptions. And guess what that creates? A massive tech debt headache that slows the whole company down. To truly understand the sheer volume of work we're talking about here, just look at the anatomy of a single, simple button component. There are 6 tedious sections required to properly document just this one tiny piece of the interface. You need the anatomy with numbered markers, the API defining properties and defaults, the variant properties, the color annotations mapped to tokens, the structural padding and spacing, and of course the screen reader accessibility specs. I mean, imagine forcing a designer to manually produce page after page of this highly structured documentation for hundreds of components. It's literally exhausting just thinking about it. And zooming in on just the screen reader accessibility alone, 3. That's the number of separate accessibility APIs designers are forced to manually cross-reference. To get it right, they have to navigate voiceover modifiers for iOS, talkback semantics for Android, and area roles for the web. Each of these has hundreds of properties. Designers spend hours just cross-referencing, and the stakes? They're incredibly high, because a single wrong property means a completely broken experience for users relying on assistive technology. No pressure, right? So this brings us to the ultimate enterprise nightmare. Manual spec writing is slow, it's highly inconsistent across different authors, and it drifts out of date almost instantly. At an enterprise scale like Uber's, this documentation process turns into a dedicated, grueling workstream. And despite throwing endless human hours at it, inconsistencies inevitably build up the very second a component is tweaked. It's basically a losing battle. So how do you fix a completely broken, unscalable process? Section 1. The magic trick. Introducing uSpec. They created a system called uSpec, an agentic system that connects an AI agent directly inside the Cursor IDE to Figma. And the workflow? It's incredibly elegant. Step 1, you just share a Figma link with the AI agent and give it a little context about states or variants. Step 2, the agent reads the file and directly renders the spec. That's it. That's the entire process. What used to take weeks of manual formatting is now reduced to a single automated pass without any messy intermediate steps. The agent goes straight from reading the component to placing completed documentation right into the Figma file. Now, what's really interesting about this is the end result. 2 minutes. A full, multi-platform screen reader spec now generates in under 2 minutes. Just let that sink in for a second. The hours of grueling manual labor, cross-referencing Apple, Google, and web accessibility guidelines, all of it is now automated and rendered flawlessly back onto the design canvas before you can even get up to refill your coffee. It's an absolute game changer for design systems. Section 2. Pulling back the curtain, how it works. To understand how it's actually doing this without just assuming it's magic, we have to look at the architecture. The system works by utilizing a dual-layer approach. The first layer consists of specific AI agent skills, where each skill carries highly specific, encoded domain knowledge. The anatomy skill generates numbered markers. The API skill extracts properties, values, and defaults. The properties skill handles variant axes and toggles. And the color annotation skill maps tokens for every single state. The real genius here is that each skill loads its own instruction file with validation rules and reference docs. So the agent doesn't just blindly guess or hallucinate, it actually selects from documented APIs. But an AI agent in an IDE needs a way to actually see and interact with the design file, right? Well, that's the second layer. The Figma Console MCP, or Model Context Protocol, acts as the bridge connecting the AI agent directly to Figma Desktop. This allows the agent to actually crawl the component tray, detect parent-child layer relationships, read the design tokens, and translate Figma's internal modeling patterns into clean, structured API documentation.
And this brilliantly illustrates the perfect marriage of two completely different technologies. uSpec combines AI judgment with programmatic scripts. The AI provides the interpretive power. It classifies the accessibility semantics, selects the right token mappings, and decides how to intelligently structure the spec. But AI isn't always great at pixel-perfect layout, so it hands off the actual drawing to programmatic scripts, which handle the precision rendering of text fields and tables directly onto the Figma canvas. Best of both worlds.
Section 3. Scaling securely at Uber. So the crucial point is, deploying a tool like this at a massive, publicly traded enterprise requires clearing some major hurdles. The biggest one, a 100% local pipeline. For an enterprise giant, security is the absolute highest priority. The Figma Console MCP connects to Figma Desktop over a local WebSocket, and the agent runs locally on your machine. This means absolutely no proprietary design data, no secret, unreleased features ever leaves the internal network. This strict, local-only execution is literally the fundamental feature that makes AI-assisted documentation possible at Uber in the first place. Because that security requirement is met, Uber can scale this across their entire organization by leveraging 6 key properties. First, security keeps the data safe. Consistency is enforced by structured schemas, not human authors. Speed gives you those specs in 2 minutes. Accuracy is guaranteed because the agent reads real token names directly from Figma, completely eliminating human transcription errors. Multi-platform generation happens in a single pass. And finally, maintainability ensures that changelogs update seamlessly. By combining these 6 properties, a system of hundreds of components can have flawlessly accurate specs generated in days instead of months. Section 4. The Open Source Foundation. What's truly inspiring about this leap forward is that it doesn't just end with Uber. Shared infrastructure solves industry-wide bottlenecks. That crucial bridge we talked about earlier, the Figma Console MCP, was actually built and open-sourced by an agency called Southwest. This proves a vital point, right? Every design systems team faces this exact same documentation drift. When teams build on each other's open-source work instead of reinventing the wheel behind closed doors, the whole industry moves forward faster. I want to read this quote from TJ Pitra, the CEO of Southwest, because it perfectly captures the spirit of this collaboration. He says, "The tools are ephemeral, but the approach isn't. When someone like Ian takes what we built and creates something we never could have planned for, that's passing the torch." It's just such a powerful reminder that open sourcing foundational infrastructure empowers incredible, completely unanticipated innovations by the community. And in that exact same spirit, Uber passed the torch right back. uSpec is completely documented at uberspec.design, and the whole system is open source on GitHub. Uber made the deliberate choice to share this publicly. Why? Well, because they recognize that when a process works this well, making it available creates far more value for the global engineering community than keeping it locked away as some proprietary secret. Which brings us to a fascinating final thought to leave you with today. As automation shrinks the gap between design intent and engineering execution, what does the future of building software actually look like? When a designer's file can automatically document itself, analyze its own accessibility, and speak directly to an engineer's code in minutes, we are stepping into a whole new world of product development. I highly encourage you to think about how these automated, agentic pipelines could transform your own workflows. Thank you so much for joining me on this explainer, and I'll catch you in the next one.